Hi folks, welcome to this quick lesson on the last bit of the rational functions chapter. So in this video we'll take a look at being able to graph functions from strange forms, and then maybe we'll take a little recap of the whole chapter, which has been about rational functions and equations. In the video description below you'll find both blank and filled in notes, so you can check those out in PDF, and you can also find the digital textbook on the Google Classroom site, and I'll also put in the pages into this video. All right, here we go. So in this video, we're going to look at what I'm calling mutant forms of rational functions. If we think back about the forms that we've looked at, let's just go and grab some here. We started off the chapter with basic sort of butterfly types where you could transform, like this kind right here. Or if you wanted to generalize, here we go. Y equals a over x minus h plus k. That was one of these hyperbolas or butterfly shapes, and you could talk about its transformations. And then we looked at some where we got it as sort of a linear over a linear. And we had all these rules that we could memorize for it, which was ridiculous. Or we could start thinking about the domain and the vertical asymptotes, different things that we could pick out about the graph. And so sort of in between those two forms, we get this thing that I'm jokingly calling a mutant form of rational function, where it has both the characteristics of having this sort of linear over linear bit, and it has a plus k at the end. So it's not very easy to analyze, and it's also no fun for us to think of in terms of transformations. So what I think you should do is convert it to a form that we do know how to deal with, that sort of linear over linear form. So over here I have one of these functions that's in a, quote, mutant form, that's got part of this linear over linear business and then a plus 4 at the end. We're going to put it together all in one fraction, and to do that I want to think a little bit about how it is that I add fractions in the first place. So I'm just going to think about, what if I had 2/3 plus, I don't know, plus 7. How do we put those together? Now somebody's going to say, you can just call it 7 2/3. Yeah, absolutely. But as an improper fraction, we'd need to turn it into a common denominator. So we'd go 2/3 plus, we'd call 7 21/3. And that would give us 23/3. The question is, how do we get that 21/3? And here's how it is. You're going to think about this as being the denominator that you want to use, that 3. So we take our 7 and we multiply it by 3/3. Now 7 is, in secret, just 7/1. Every number is a fraction over 1. That's what lets us get this 21/3 business. We just multiply by the denominator that we want. So that's going to be really similar to what happens in this example up here where we have some algebra. I want to put these things together, and I'm going to have to use a denominator. I could say common denominator, but it's really the only denominator, of 2x plus 1. Okay. So how do I do that? Well, I take that 4 and I times it by 2x plus 1 over 2x plus 1. Okay. And really that 4 is just a 4/1. That's going to let me put things together. Now I'm going to take it slow. I'm going to do it in separate steps here. And I think it probably makes sense for you folks at home to pause here and maybe do this on a sheet of paper rather than just watch me do it. So what would I get? I'd get f of x is, I still have this 3x minus 1 all over 2x plus 1. And then I'll have plus, let's see, 4 times 2x and 4 times 1. So that's 8x plus 4 all over, let's see, the bottom, 1 times 2x plus 1 would just be 2x plus 1. If I want to show all the little steps here, just like when you have 2/3 plus 21/3, now we can just put it together and call it 23/3. You could also show that as, once we've got the same denominator, our numerators can just be added, or our tops can just be added. Okay, let's do that with the algebraic expression here. So I'd have 3x minus 1 plus, if you want to be really paranoid here, you could say plus all of 8x plus 4. You could put some extra brackets in there. Not really needed because they don't do anything. But if you had subtraction, you might have to be careful. And now I can put my terms together. I'll have 3x plus 8x, which is 11x, minus 1 plus 4, that's plus 3, all over 2x plus 1. Okay. At this point, I have it in a form that I've seen before. I've got it in, well, that kind of form, or where do we have it again? To start with, we have it over here, ax plus b over cx plus d, just a single fraction. And here were the steps. We would find the domain. We'd use the domain to find the vertical asymptote. We'd find the horizontal asymptote by dividing out sort of our drivers on top, our coefficients of x. We'd find the y-intercept, the x-intercept, and then plot what we know. So let's do that. Now that we have it in this form, it'll be a nice refresher of that technique. So I need to figure out the domain. And the domain comes from whatever number causes the bottom to be 0. Now, a lot of you are going to look at this and just know that the number -1/2 makes this whole bottom become 0. If not, you can make a little equation. You know that 2x plus 1, that's the thing that can't be 0. If that's 0, then you're dividing by 0, which is no good. So 2x can't be equal to -1, or x can't be equal to -1/2. There's the domain of this function. Okay, and if we, again, look back at it, if you put in -1/2 for x, you would have division by 0, which is bad. So there's our domain. Once I know that, I know my vertical asymptote is going to be at x equals -1/2. And we could start drawing this if we wanted to. We can just keep describing as well. Okay, my horizontal asymptote. That comes from dividing out my drivers, 11x over 2x. So let's see. I'll get rid of that just so I don't have it there the whole time. But it would come from 11x over 2x, or 11 over 2, or 5.5. So really how I'd like to say this is either as 11 over 2, if you want to use improper fractions, or as y equals 5.5. Let's find the rest of the stuff. We need to find the y-intercept. So y-intercept means sub-0 for x. So we'd get 11 times 0 plus 3 all over 2 times 0 plus 1. What would that be? That would be 3 over 1. That's our y-intercept, is 3. And I'll organize this stuff all nicely on the next slide. Lastly, I need to find my x-intercept. To do that, we sub 0 for y. Okay? And remember, y and f of x mean the same thing, so I'd get 0 equals 11x plus 3 all over 2x plus 1. Looks like a miserable equation, but in equations that have fractions, we could just multiply both sides by whatever denominators we want to get rid of. And what am I going to get here? I'm just going to get still 0 on the left equals 11x plus 3, or 11x equals -3, or x equals -3/11. There's the x-intercept. So aside from putting it in this form right here, none of this has been new, but it may be something that's kind of fallen out of our brains because it's been a few days since we've done some of these. Okay, I'm going to put this all on the next slide, sort of nicely organized, and then we'll actually graph it. Okay, there's all our information. If you really wanted to put the range in here as well, you could say that the range is y not equal to 5.5. We'll see why when we plot it in just a second. Let's just put all this stuff in here. So here's -1. That means this asymptote would be back here of x equals -1/2. Okay, I have a horizontal asymptote at 5.5. 2, 3, 4, 5.5 would be right here. I'll try and do that as straight as I can, or as horizontal as I can. There we go. There's y equals 5.5. And now I'm going to plot my y-intercept. So this is the actual curve, so maybe I'll pick a different color. That would be at y equals 3. The x-intercept is negative 3/11ths, so that's somewhere, I don't know, around here-ish. It's not quite at negative 1/2. And at this point, I'm just going to make the shape. It's got this butterfly or hyperbola shape. And that must mean that the rest of it exists up here. Now there's some mixed practice that you can do in the book around this idea. You can find it on 209. I just want to take a second and go back through the whole chapter so we can have a little recap. And then at the end, I'll put up a video of the different problems that have been assigned from the book. So this chapter started with looking at your basic reciprocal function, 1 over x. We took that and we transformed it. We got this form a over x minus h plus k. That easily told us about our stretches, our reflections, and our shifts and lifts. After that, we considered rational functions in this linear over linear form, which required a different kind of technique. And here was that technique, or a way that you could consider the technique for graphing from that linear over linear form. That was all the graphing stuff. Then we got to rational equations, for which we found a common denominator, and then multiplied both sides by that common denominator so that we could get out of fraction land as quickly as possible. We always check to make sure that our solutions aren't restricted values. After that, we looked at finding the equations of inverses, which had its own little trick. Of course, for an inverse, you switch x and y, then we'll get rid of fractions. And the trick was to collect our y terms on one side, take out y as a common factor, and isolate y. So here's an example of that. We switched x and y, we multiplied by the common denominator, that's in green, and then we got our y terms on one side and took out a common factor of y. Lastly, we have these, quote, mutant forms, where we put it to one or the other of the forms. I think you should put it in that linear over linear form. And that brings us to some practice here. I've got a for fun question as well. You can pause if you want to look at what numbers these are. And to recap, all the assigned work from Chapter 4 was all these questions. So if you want to go and check some more of these out, that's great. If you want to do a smattering of them, great. If this is something that just fell off your to-do list, then maybe this is a good opportunity to take a look at some of this stuff. All right, I'll show the work that's from the book. All right, starting with the material that was assigned today. This is all kind of chapter review type stuff. So here's question 1 from the chapter review where it's sketching some graphs. Question 2, again, sketching graphs. And then 15, and of course you can pause this video and take a closer look, or you can check out the PDF. There's 15. It also said 17. There's another one. And it said 25. It should be 22, I think, because there's no 25. And then we can head back and look at the stuff on 206. So this is stuff that was assigned a little while ago. 206, number 1. Number 2. Number 4 is on this page. And then number 5 was the one about the rational equations. So there you go. Number 6 was also about rational equations. Right over here. And then 7, 8C, if you want to do it. After this, it's not the basics anymore. There's number 10, which is kind of interesting. Number 11, which is kind of interesting. And then number 12, BC, were ones that you could do. And number 13. So it depends how deep you want to go on this, but if you want some more rational practice, there you go. And then from the first section, we had page 199, which would be right here. Okay. And here's what was assigned from that. Number 1, A, C, E, G, just writing down the domain range and the vertical and horizontal asymptotes. Number 2, sketching. And number 3 was a matchy-matchy question. So you'll probably need to look at, there are the equations, and here are the graphs to compare them to. There are 3 of them. And here's the last one. So that's it for new material for today, folks. The only real new thing was those mutant forms of rational functions. Aside from that, it's just making sure that you haven't forgotten everything about the other graphing and solving and inverse techniques we've looked at in Chapter 4. Take care of yourselves, and I'll see you soon. Bye-bye.